Do you see my screen? Okay.
Yes, I am muted. Thank you. Perfect.
Yeah, okay. So, hi everyone. I will talk about scanning tunneling microscopy, which is known as STM. So, in 1981, Benning and Roher invented STM, which is a device that you can use to do scanning to obtain an image with real space, an image with atomic resolution. So after 5 years, they were awarded for a Nobel Prize for inventing STM. So what is the principle or the physics behind an STM? So it's a quantum tunneling. We know that in a quantum approach, electrons, they can tunnel through a potential barrier where the probability density of the electron will depend on the potential barrier. So how we can take this and apply it in STM and not only have one electron tunneling, we can have a current tunneling. So basically in STM, so you will have the sample and you will have the STM tip. The tip it's used to probe the surface, and the small voltage will be applied between the sample and the tip. And in order to have a tunneling current, the separation distance should be kept so small. So usually in the scanning, in the STM, the separation distance it's in a range of 10 angstrom. So basically, if you wanted to do the scanning, so you will have your sample, you have the STM tip, a voltage applied between them. So we want to keep the separation distance so small. How we can achieve this? It's by mounting the STM tip on piezoelectric tube. And we know the nature of this material can allow us to control the separation distance precisely. So when you do the scanning, the STM tip will move above the sample and the current variation will be recorded and then processed to have a topographical image of the surface. So here on the right, you can see the curvature of the STM tip, and from the dimension, you can notice how much is small the apex radius of the tip. So by this, we will be allowed to have an image with atomic resolution. So if you want to do the scanning, you have to choose either one of the operation modes. Let's say your sample has a homogeneous surface, you can go ahead with constant current. In a case you want to do the scanning in higher speeds, you can choose the constant height. Here on the right, you can see two images that were obtained by STM. So usually the STM, it's used to study the atomic structure of the surfaces. Also, it can be used to study the conductivity and the heat transfer of the material. Nowadays, researchers, they are using STM to study the biological system like DNA. So if you want to buy STM, like in the picture, I used one, it's look like this one on the right. You can buy it from NanoServe and RHK Technology. These companies are very specialized in STM and AFM. The price, it will be ranging from $30,000 to $150,000. The precise of the device, it will be in the picometer range, while the resolution that you will get, it will 0.1 nanometer literal resolution, and for 10 picometer depth resolution. So the last thing that I want to say, and just the professor mentioned that STM can be used to displace the atom. So basically you can choose an atom and displace its position. So IBM has published a film that made by manipulating the atom. So by this, I say thank you for listening, and I welcome any question.